Hello, this is my second lab report for Physics 2211 regarding the movement of an object with gravity and drag force. The purpose of this experiment is to study the motion of an object due to gravity and drag force and make predictions using Newton's second law, which is interesting because F net is no longer zero, indicating a changing velocity. This is demonstrated through the two equations showing the change in position and velocity on the right. One can see that if F net is not constant, then a new Vf will influence the change in position. F net is not zero because drag force is factored in with the equation force of drag is equal to b times velocity squared, where b is a constant. While b does not equal zero, F net will not be zero. Once the F net starts to approach zero, change in velocity will become constant, meaning that F drag will approach gravity to have a constant acceleration. I chose falling baby wipes for this system, used Tracker to observe the motion, and used GlowScript for the other models, which yielded my results. The results of this lab showed my models were a poor fit for the observed data since the observed position matched more closely to my positions with gravity rather than those with drag. I filmed the video of the wipes falling from rest, then uploaded it to Tracker, which then I used to keep track of my movement observations. Additionally, I used GlowScript and the base code given to model the predicted movement of wipes with gravity initially and then with drag. Finally, I compared the three sets of data by putting it into a line graph. Here is the video I uploaded to Tracker. I edited the frames to start at 37 so the ball would start with an initial velocity of 0 and did it at 51 when the ball went out of view. The initial velocity is 0 since the ball begins at rest, and the initial position was measured in Tracker, which was at the origin. You can see the graph of position versus time is a lovely curve, demonstrating the change in velocity as time continues. While using GlowScript, I edited the initial position, mass, velocity, and corrected the equations to update the position, velocity, and F net. With this predicted model, one can see a nice curve that demonstrates a change in velocity. Here, I compare the results from the predicted model to my observed model, and we see the prediction is a bit off since this model does not account for drag. The predicted data falls faster than normal, so to account for this, drag must be calculated in GlowScript. In order to account for drag, we use the equation force of drag is equal to the force of weight, or mass times acceleration, divided by the square of velocity, which was done using the last two observed points in Tracker. B was edited to be 0.058, and the graph showed that the velocity was changing. This graph of changing velocity as time continues demonstrates that the object is not at terminal velocity since velocity is not constant yet, though it begins to level off. Here is the comparison of the predicted and observed positions. This appears to be a poor model because the positions with drag should be closer to the observed rather than farther off. The gravity positions also line up more closely with the positions than the drag does, which should not be happening. Overall, my models left something to be desired and were a poor fit for this experiment. There could be many reasons for these errors, such as my choice of object. I chose baby wipes to try to create more drag on the object, but this may have thrown off my project overall. There could have also been inaccuracies with my point tracking in Tracker. The final velocity may not have been as accurate as it could have been for B due to a larger than acceptable delta T. There was also a strange issue where my Tracker appeared to break down every time I tried to track position, which would not stop no matter how long I restarted my computer for, although I doubt this impacted my final results. So, which graphs show terminal velocity? Unfortunately, none of my graphs demonstrated terminal velocity since there were no true constant velocities. The graph on top with drag began to level off, indicating that it approached terminal velocity. However, it is cut off before terminal velocity could be attained. What would happen if the object were thrown down rather than starting at rest? If the object were thrown down instead of dropped, terminal velocity would remain the same but would occur faster. This is because velocity would not begin at 0 and would approach the terminal velocity at an accelerated rate. This can be easily modeled by GlowScript by editing the initial velocity as shown. These graphs show the velocity begin to level off at around the same rate, but with the edited graph on the bottom happening sooner as predicted. Thank you for listening to my project.